Hello everyone, thank you for being here. I'm Fahmid. I am a PhD student in North Carolina State University. I work with Dr. James Lester. Let me present our work on effects of modalities in detecting behavioral engagement in collaborative game-based learning. So collaborative game-based learning environments are small games that are kind of designed to teach students particular curricular content. For example, teaching them about ecosystem science or about diseases or stuff like that. And when these games include a collaborative problem-solving component to it in the gameplay in a way so that student can discuss within a group and then they have group-based, group-level problem-solving, then it's collaborative game-based learning. It has been seen that this kind of environment has been shown to have a increased motivation and engagement as well as promote cognitive and effective outcome in most of the K-12 studies. We know from the earlier research that when students are engaged in this kind of environments, they tend to have a better outcome as learning gains, but also they have a positive effect on the groups in general. And then when students are disengaged, they not only harm themselves, but also harm the people in the group in general. So it is important to understand when students are getting engaged or when they are getting disengaged when they are using game-based learning environments. So many work have used this kind of environments to on a single or multiple modalities to understand when students are getting engaged or disengaged, but most of the works are focused on using a single modality as ground truths. We know from multimodal learning analytics is that students' behavior can vary wildly based on the modality of observation. So it depends on what modality you are using to observe the behavior itself. Limited work has actually investigated the impact of unimodal or multimodal features in conjunction with unimodal and multimodal ground truths in collaborative game-based learning. So what we propose here is to investigate the impact of multiple modalities to observe, identify, and compare students' disengagement behavior of middle school students in collaborative game-based learning. We define disengagement behavior as behaviors where students show a disruption or their learning flow is impeded. And we observe that through two different modalities, namely the in-game chat and the facial video recordings of the students. More specifically, we asked the following two research questions when predicting students' disengagement behavior in game-based learning environment. And the research question one is that do performance of these predictive models using unimodal features vary by the modality of the ground truth? And the second one is that do models using multimodal features always outperform models using their unimodal features? Before going further, I'll discuss a little bit of the related work in behavioral disengagement. So disengagement behavior has been studied thoroughly for the last decades or so, but the definition of disengagement or engagement of student varies widely. It can mean disengagement as moment-to-moment disengagement. It can also mean disengagement in terms of semester-long disengagement. It can also mean cognitive, affective, or behavioral disengagement. For our work, we are specifically focused on moment-to-moment disengagement and for behavioral disengagement of students. We know from prior study that positive behavior, positive student behavior lead to improved learning outcomes and negative behavior has worse learning outcomes. But not only that, we also know that student behaviors such as postures are indicator of behaviors that entails with boredom, frustration, or mind wandering, and negative behaviors often lead to disengagement or disinterest. In terms of detecting behavioral disengagement, prior work have used different modalities to understand when disengagement happens. For example, keystrokes has been used to detect disengagement behavior. Video modality has been thoroughly used to understand when disengagement happens, like mind wandering and frustration and so on and so forth. In-game chat data has been leveraged to build disengagement detection models to detect particular type of disengagement, such as ineffective discussions or disruptive talks. There has been work that has also been used multiple features, such as like videos and audios and gestures, together to leverage the models to detect engagement behaviors or disengagement behaviors of students. But actually limited work has actually investigated the multimodality of the ground truths itself and have a contrast on that front. With that, let me move into our method section. So we have used Crystal Island EcoJourneys, a game-based learning environment that is narrative-centered learning that teaches students about ecosystem science, specifically designed for the middle school students. Students in the environment work in groups of 3 to 4 together to investigate a certain sickness of fish. They explore the island, collect evidence, and then talk to different non-playable characters to gather those evidence. And they can use an in-game chat tool to discuss what they have found. They can share and negotiate, help each other through that chat tools anytime. There is also a voting mechanic for them where they kind of vote through the evidence to have a collaborative understanding and a collaborative consensus of their findings. And it usually takes about 2 to 3 hours to complete the whole game as a group. For our study, we have used facial video recordings of the students as well as their in-game chat data. There were a total of 26 students, 18 of them were males and 8 were females, all aged between age 11 to 13, all 6th graders and 7th graders, as we can see. We did 2 sessions of 1.5 hours each. There were 7 groups. Each group was accompanied with a facilitator to help them navigate the problem. And we collected a total of 48 hours of video recordings and about 3,650 chat messages during those 2 sessions. So now that we have chat data and as well as video data, we first started annotating them separately as engaged or disengaged cases. For the chat data, we looked into individual chats, and if the chat were related to content or topic, or if the chat were socio-emotional but positive and encouraging, we marked those as engaged chat because those have positive effects, whereas anything other than that is marked as disengaged. For facial video recordings, we used a 10-second window to mark each window as engaged or disengaged. When students were working on their laptop or taking notes or focused on the monitor, we marked those as engaged. But other than that, when students were working on their phone, playing games, or even sleeping, those were marked as disengaged. About 70% of the chat data were tagged as engaged, and about 77% of the video data was tagged as engaged. Now that we have 2 different sets of ground truths, one coming from the chat data and one coming from the video data, we wanted to understand when do they agree with each other and when they don't agree with each other. So for that, to have a comparable results, we also made a 10-second window for the chat modalities and propagated the current state of their chat-based engagement or disengagement throughout the next signal. Here is an example of a student going through the game-based learning environment, and the orange dotted line here shows that the signals coming from the video-based modality of ground truths, and then the blue dotted line shows the signals coming from the chat-based ground truths modality. As we can see that not always these 2 different ground truth sets agree with each other. There are cases where one doesn't agree with each other. And in the paper, we've discussed all of these events thoroughly, like what the possibilities could be, but I'll just give an example here as like the case of E. Here, the video-based modality shows that students are engaged, but the chat modality shows that they are not engaged. What happened here when we looked into it, we saw that students were talking about their physical conditions, so they were like really serious about it. So the video modality didn't show that they were disengaged, but the chat was definitely off topic because it was a personal discussion. So that's why we know from the chat side that it was a disengaged chat topic. In general, we found that about 70% of the segments agree with each other and the rest 30 does not. So based on that, we created 4 additional sets of ground truths based on different heuristics. For example, the chat first heuristic prefers whenever there is a disagreement, we would prefer the chat-based signals over the video-based signal as ground truths, and so on and so forth. One thing to notice here is that the engaged first set of ground truth has a very imbalanced data. It has only 6% of the data that would come later. Based on these different sets of ground truths and the combination of ground truths, We also created different sets of features. One feature coming from the chat modality itself, one from the video modality, and then a mix of features together. So the chat-only feature coming from the chat modality is a 256-dimensional features representing one single chat message. The video modality is a 49-dimensional vector representing action units and gaze and pose estimations, again for the 10-second window. And then the multimodal feature is a combination of both. And we used a binary classifier to understand how these features are impacting the different sets of ground truths we have in conjunction. So this is the complete set of results, but I won't go through each of this. I'll just focus on how to read the table, and we'll look at specific parts of it. As far as the major columns goes, these columns represent the three sets of features we have. So the chat-only features, the video-only features, and the multimodal features that combines both. For the major rows here is the 6 different ground truth sets we have. One is chat-based, and then the other one is video-based, and then the rest is the combination of these two. Each row represents a single classifier. We've tried 4 different classifiers. And in most of the cases, random forest is always performing the better. So from now on, I'll just focus on random forest results, but the rest of the results are also in the paper if you want to look. So looking at that and specific cases, let's look at the ground truth coming from the chat data. So we are only concerned with the labels that are come from the chat data. With that, we can see that when features are also coming from the chat data, the performances of predicting students' engagement or disengagement is really good. But this is not true when the features are coming from the video modality. Combining these two together doesn't improve the result much. What I mean by that is that when we are only concerned with chat labels, labels coming from the chat data, multimodal features does not improve the performance that much. The opposite becomes a little bit true when we are looking at the labels that are coming from the video data. So when we are using labels from the video data, we see that features also coming from the video data are performing really good. Chat data is still very relevant. It's not performing as well as video features, but it is relevant. And when we combine these two features together, we get a boost in our predictive accuracy. For the rest of the 4 different combination of labels, we see that both of the 2 different modalities are performing almost similarly, except the case of engaged first for video features. And this could be in the case where, as we said before, the class is really highly imbalanced and the video doesn't actually capture those nuances. But in all of these cases, multimodal features are always performing better. They are improving the result of the predictive accuracy. So what we found as a whole is that models using unimodal features perform better if the ground truths are also unimodal and of the same modality. What I mean by that here is that when we are using unimodal features such as features coming from the chat only or the video only, ground truths that are also on the same modality are actually better. But the opposite is not true. For example, if the ground truths are coming from the video modality and we are using features from the chat modality, the performance are not that good. Secondly, what we found is that multimodal features sometimes improve the performance, while other times it does not improve the performance when the ground truths are coming off the single modality. What I mean here is that when we are using chat-based modality as ground truth, multimodal feature, as we have seen, does not improve the performance. But when we are using video-based modality as ground truth, multimodal feature does improve the ground truth, improve the performance of the predictive models. Multimodal features does improve the predictive models when ground truths are combined. So when we are defining labels as a combination of different modalities, in those cases, the performance can be improved with multiple features. But one thing to notice as a rule of thumb is that no matter how the ground truths are defined, multimodal feature never hurt the predictive performance. To get back to our research questions that we have asked, the first question was, do performance of the predictive model using unimodal features vary by the modality of the ground truth? So the answer is yes, models using unimodal features perform better for ground truths coming from the same modality. Our second research questions, do models using multimodal features outperform the models using unimodal features? And the answer here is that it's not always the case. It depends on the modality of the ground truth. If the modality is a combination of multiple modalities, then yes, otherwise no. So in general, the predictive performance of vary across different ground truth sets and modality of features. And we've seen that multimodal features can always ensure maximum predictive accuracy. But it's also the case that collecting additional modality is expensive and it has other concerns such as security and privacy. So when it's important to understand when we need additional modalities and when we don't. For example, when ground truths are unimodal, including additional modality as feature is not always necessary. But when ground truths itself are a combination of multiple modalities, in those cases, multiple features can boost the predictive performance. In conclusion, we identified that disengagement behavior in collaborative game-based learning environment is an important thing to identify. And limited work has investigated the trade-offs of using single versus multiple modality of features with respect to modalities of ground truths. We found that multimodal features can ensure maximum predictive accuracy in predicting disengagement behavior of students, and unimodal features are suitable and often sufficient for detecting disengagement behavior. As for future work, we are interested in exploring other type of modalities such as in-game trace logs or collaborative processes. It would be also interesting to see deep learning models, specifically contextual models like LSTMs or RNNs, and how they improve the performance of these models. And actual classroom study using this framework and to evaluate how this framework is performing. I'd like to thank all my colleagues and the support of NSF. Thank you.